Okay, so we next talk about some particular values of sin x and cos x. Okay. See, these are some particular values which you need to remember for this chapter. That's sin 0, sin pi, sin 2 pi, sin n pi, and sin 2n pi. All these values they are equal to 0. Okay, so the main values are these values: sin 0, sin 2 pi, sin n pi, and sin 2n pi. All these values they are equal to 0. Next, cos pi, cos 3 pi, cos 5 pi, all these values they are equal to -1. Okay, then cos 2 pi, cos 4 pi, cos 6 pi, all these values they are equal to 1. Okay, so cos at the odd multiples of pi it is equal to -1. Cos at the even multiples of pi it is equal to 1. Okay, so cos n pi, it is -1 raised to the power n. Okay, because n, when n is odd, okay, it becomes -1. When n is even, it becomes +1. Okay, cos 2n pi, this is equal to 1. Okay, and cos 0, it is equal to 1. So these are the three particular values, okay, which are used for solving the question. Cos n pi is -1 raised to the power n, cos 2n pi it is equal to 1, and cos 0 it is equal to 1. Okay, so you need to remember these values. Okay, now next is property of definite integral. This property is mainly used integral minus a to a f of x into d of x. So this is equal to 0. Okay, I mean value of this integral is 0 if f is an odd function. Okay, I mean if the function inside the integral sign, okay, if you find that it is an odd function, then the value of this type of integral it just becomes 0. Okay, and if you find that this function is an even function, then what we do, we write 2 outside the integration sign, and the lower limit becomes 0, 0 to a f of x into d of x if f is an even function. So this is also the very important result which is used for solving majority of questions of the Fourier series. Okay. Now next we learn about U into V rule of integration without using integration sign. Okay. See how to apply U into V rule without using integration sign. First of all, write U in your first function. Okay. Then V sub 1. V sub 1 mean integration of v. Okay, v sub 1 mean integration of v minus u prime mean derivative of this u function. Okay, then v sub 2 mean that this is the integration of this v1 function. V sub 2 is integration of v1 function. Okay, plus u double prime. Okay, and then v sub 3. Okay, so this formula goes like this. Okay, here it is minus. Here we use alternate sign, positive negative positive negative positive negative. Okay, so I just show you some examples of this. For example, suppose here you have x and here you have e raised to the power x into d of x. Okay, so apply here u into v rule. So what it is, it is u mean write this function as such. Okay, integration of v. So what is the integration of e raised to the power x? It is e raised to the power x. Okay, minus derivative of u. What is the derivative of x? It is 1. And integration of v. What is the integration of e raised to the power x? This is simply e raised to the power x. So what it is? It is x e raised to the power x minus e raised to the power x. Okay, so in this way we apply u into v rule without using integration sign. Okay, and as mainly in the Fourier series we have limits also, so we do not add any constant while integrating it. Okay, so next, suppose that we have x into sine nx. So here again u integration of v. So what is the integration of sine? It is minus cos nx by n minus derivative of x is what? It is 1. Then integration of this function, which is minus sine nx by n square. So it is minus x into cos nx by n minus minus plus. So it is sine nx divided by n square. So in this way, we can apply u into v rule in practice for solving the questions of Fourier series. Okay. Now we solve one more example here, like integration of x square into e raised to the power x into dx. Okay. So see u, which is x square, integration of v, integration of e raised to the power x is e raised to the power x minus derivative of this function, it is 2x. Okay, integration of this function, integration of e raised to the power x is e raised to the power x plus derivative of 2x function is 2, and integration of this e raised to the power x function is e raised to the power x. So in this way you can apply u into v. Okay, so more about it will be discussed in the next lecture. Okay, thank you very much.